This is a summary of mechanical engineering, which is one of the three biggest disciplines of engineering. And you can think of mechanical engineering as the study of physical machines, that involve force and movement. Every discipline is divided up into subdisciplines, and the core sub areas for mechanical engineering are mechanics, that has to do with the deformation of materials under load and relationships between forces and deformations. Dynamics, which involve the relationship between forces that are applied to things and how those things move. Thermodynamics, which relates mechanical energy, motion, and forces and things to thermal properties. An example of that would be like a power plant where you use thermal energy, heating up a material to get mechanical energy out of the system. Material science, that is the study of the properties of different materials. And then these last three are newer areas. Composites, so that's the study of the combinations of different materials. Mechatronics, which is the connection between mechanical forces and motion and electronics. Clearly, that's something that's important in robotics. And nanotechnology. Every university that teaches mechanical engineering has different requirements for what kind of classes you'll take, but there's a lot of overlap. Mostly the different programs have you take the same classes. And so here is just sort of a likely curriculum that you would take if you studied mechanical engineering. First, the math that you would take would be, like with almost all the areas of engineering, you'd have to take all the calculus sequence. You'd have to take some differential equations. Linear algebra, which at Normandale is part of the differential equations class, Calc 4. And statistics. For science classes, you would have to take physics, usually 2 semesters of physics, calculus-based physics, and chemistry. And then once you're done with all this, maybe you can take some engineering classes before you're done with all of this, but for the most part, you do all these background classes first, and then you go into the engineering classes. And the engineering classes you would have to take at most places involve statics. That's the study of the forces in a structure that is not moving, or in some cases is moving but has no acceleration. Dynamics. So that's the study of how objects move when forces are applied to them. And when I say objects, sometimes we're talking about complicated structures that where different bodies are connected by joints. So this is stuff that you could use in biomechanics to study the human body, or in robotics. And then fifth, most universities call this mechanics of materials. At Normandale, we call it deformable body mechanics, and we call it that because that's what the U calls it. But you should know that these are the same thing. And this, let's see, there's one more that goes in here. Number 6 is thermodynamics. And these are all the things that you can take at Normandale. And then all the rest of them are things you would have to take after you transferred. The first one of these is material science. And then you'd have to take a class in fuel, combustion, and internal combustion engines. You'd have to take a class in fluid mechanics, so studying the way fluids move when they're subjected to pressures and temperature variations and things like that. Vibrations. So a big part of mechanical engineering is trying to figure out how to limit vibrations, because those often cause damage in things. And then the last one is manufacturing engineering. And in different programs, in some you might have to take all of these. In some programs, maybe there are other requirements, and just you have to choose a selection of these as your technical electives to take. But this is kind of the collection of classes that sort of make up a mechanical engineering curriculum. The median pay for all engineers in all disciplines is about $102,000. For mechanical engineering, that median is about $99,000. I have it as $99,510. So half of the working engineers in the world in America, I should say, make more than that, and half make less than that. As I mentioned at the beginning, this is one of the 3 big branches of engineering. And so in 2023, there were 291,900 people working as engineers in the US. And the future outlook for mechanical engineers is that there's going to be a lot of growth in this area. 11% growth is expected, which is much faster than the average growth over all industries, not just engineering, but all industries. One thing you're going to see is that generally for engineering jobs, more growth is expected than in other areas. So much faster than average for mechanical engineers. And then the work environment for mechanical engineers is usually office work. So mechanical engineers don't tend to do a lot of work out in the field or anything like that.